Outreach and Diversity Officer at the Royal Astronomical Society. And you are all muted, so if you do want to chat to me, please type it in the chat function, or get the adult with you to type it in the chat function, because while I'm speaking, I might not be able to realise that you're trying to ask me a question. So I will keep an eye on the chat function if you've got any questions while I'm talking. So today we are going to learn about comets, asteroids and meteorites. And there's a meteor shower that you can try and have a look at night time if you're old enough to stay up until it goes dark. And I'm going to do a little presentation about asteroids, comets and meteorites first, and then we will have time for some question and answer session. So I'm going to share my screen, and if at any point there are any technical difficulties or anything like that, please do wave at me or chat to me through the chat function, just in case the screen goes off or anything like that. And those of you that haven't used Zoom before, you are all muted, so I can't hear you, but I can see lots and lots of very happy smiley faces, which is fantastic. And if you do want to ask me a question, then do it through the chat window. Okay, right, let's share this screen. Okay, so this is the second of the primary sessions that I've done. If you weren't able to come to the first one, then do let me know if you want a recording, because we have been recording them. So if you missed the first one, do let me know if you want a recording. And the first one was about the solar system and the objects, well, the planets in the solar system. And today we're going to be talking about comets, asteroids and meteors. But for those of you that haven't met me before, like I said, my name's Sheila. I work for the Royal Astronomical Society. I'm a space scientist, a physicist, and a teacher. And I've had a really cool life because of working in the space industry. So if you're interested in space, then you should certainly have a think about a career in the space industry. I did physics with astrophysics at Manchester University, and then I carried on studying, and I did something called a PhD in planetary science, where I learned all about the planet Saturn using a spacecraft called the Cassini spacecraft. So Saturn is my favourite planet. And it's been a really fantastic journey. When I was allowed to, I was able to travel all over the world. I've met some amazing people, and it's a super fun job to have. Now, the Royal Astronomical Society is a membership organisation representing astronomers and geophysicists all over the country and internationally. The building is based in central London, just off of Piccadilly, in a building called Burlington House. And obviously it's closed at the moment, but when it is open, you are able to visit on open house days. And you can see the cool council room, which has lots and lots of great artifacts, space artifacts in it. And we have one of the biggest collections of books in our library. And we have books from people, written by people like Galileo and William Herschel and Isaac Newton in. So if you are interested to come and visit when things go back to normal, then do get in touch, and we are able to do visits. So our first president was called William Herschel. There's a picture of him in the bottom left screen, bottom left of the screen, and he was an astronomer. He actually found the planet Uranus, and he had a very famous sister called Caroline Herschel, who I'm going to talk about during today's talk. And one of the more current presidents is Professor John Zarnecki. His picture is left to the right of William Herschel. And I show these pictures because it kind of shows you that in 200 years, so the society is 200 years old this year, in 200 years, you can see the face of astronomy hasn't really changed very much. So I want you guys to become astronomers and geophysicists and scientists in the space industry to take the Royal Astronomical Society to another 200 years of great astronomy. So if you are interested, there are lots and lots of cool jobs out there. You could, of course, be an astronaut, and there's a picture of Tim Peake there in the middle. But it's not just about being an astronaut. You could be a research scientist, you could be an engineer, you could be a teacher, you could be an astrobiologist and look for life like us within our solar system and beyond. Or you could be something unusual like a space weather risk management. You could work in the Antarctic, you could work using data from the bottom of the ocean, or even more unusual jobs in the space industry include space artist, space lawyer, space science presenter, space doctor. Basically, if you like space and you like other jobs as well, you could work in the space industry. Really, this is absolutely honest, but for example, NASA recently advertised for a space vet because they're planning on taking more and more animals into space and they need somebody who can take care of them. So basically, if you are interested in space, there is a job in the space industry for you. I haven't met Tim Peake, the astronaut Tim Peake yet, but I have met Helen Sharman, who was the first British astronaut. She's an absolutely fantastic woman. And I've met some Russian cosmonauts as well. And I have met other sort of space celebrities as well during my job. Okay, so my first question to you, and feel free to answer via the chat or just to chat to the people that you're with at the moment. What do we have in our solar system? So my first question to you is, what do we have in our solar system? Okay, so feel free to chat to the person next to you or type it into the chat box if you want to. So my question is, what do we have in our solar system? And people are replying saying stars. Well, we have one star, which is the sun. And we have planets as well. Yeah, fantastic. Moons, excellent. So the Milky Way is not in our solar system. We do have comets and meteors. The Earth is definitely in our solar system. Asteroids, meteors, Mars, satellites, fantastic. Space rocks, excellent. Good answers there. So what do we have in our solar system? We have the sun. The sun is at the center of our solar system. It is the only star in our solar system, but it is the most important star to us because it gives us the energy and the light that we need to survive. We also have, what else do we have in our solar system? Oops, sorry. We also have the planets. We have 8 planets, 8 major planets in our solar system. Hopefully you know them. If not, feel free to get the recording from last week. Those planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. When I was little, I was also taught that Pluto was a planet, and it's still in our solar system, but it has been sort of downgraded to a dwarf planet. And that's for various reasons, including it's very, very small. So we also have moons in our solar system. We, the Earth, have 1 moon, but Jupiter, for example, has over 60 moons. We have asteroids. We have comets. We have artificial satellites. And we have meteoroids. And we have other things in our solar system as well. We do have space debris and junk and rocks. And sometimes we do get objects from other places entering into our solar system, like asteroids from other places in the Milky Way. The solar system is a very, very busy place. And we are still finding out a lot more about the solar system while with planetary science. So human beings have only ever been as far as the moon, but we have sent spacecraft to pretty much all of the planets in our solar system to find out more about them. And some of those spacecraft have actually carried on journeying past Pluto to the outer edges of our solar system and further on. So this is just an artist's impression of our solar system. We've got the sun, then Mercury, Venus, Earth, Mars, then the asteroid belt, then Jupiter, Saturn, Uranus, and Neptune, and some of the other objects in the solar system, including the Kuiper belt and some comets there as well. So the solar system is a very, very busy place, and it's not just about the planets. So one of the questions I've had is, so what is the Milky Way? Well, the solar system is where the planets and the sun are, and the Milky Way is the galaxy that we live in. So the solar system is part of the Milky Way. The Milky Way is a galaxy made up of lots and lots and lots and lots of stars, like our sun, of which our sun is just one of them. Okay, so next question. There are 3 objects on this screen. There's the top one, There's the bottom left and the bottom right. Any ideas what any of these objects are? And again, chat to the people that you're with, or feel free to send me a message on the chat. So there was a question just about the screen before saying, why do the planets in the picture of the solar system look so close? Basically because the picture is misleading. And I spoke about this, the scale of the solar system last time. The solar system is absolutely massive. It takes a spacecraft about 10 years to get from Earth to Pluto. So that solar system is absolutely massive. Okay, so can you identify these three objects? And we've got shooting stars, meteorites, moon rock, a moon, a comet, a fireball, moon rock, shooting stars, asteroids, meteors, comets. So yeah, you're all getting the hint. So the top middle picture is what we commonly call a shooting star. But by the end of this talk, you'll know exactly what that is made from. The bottom left is an asteroid, and the bottom right is a comet. And we are going to learn more about all of those things right now. Okay, so the next slide. What we group all those things, asteroids, comets, and meteoroids, into a term called near-Earth objects. Near-Earth objects, because they do come in and they orbit the sun, and sometimes they get very close to the Earth. So comets, meteoroids, and asteroids are referred to as near-Earth objects. Comets are basically massive, dirty snowballs. And when I say massive, they can be the size of London, or they could be the size of England. So really, really, really big. And they're basically big balls of dirt and rock and snow and ice. But they do orbit the sun. They are part of our solar system. Asteroids are much smaller, and they are rocky. And they also orbit the sun, but they're much, much smaller than planets. So that's why they're not planets, even though they do orbit the sun as well. And then meteoroids generally tend to be rocky fragments. Maybe they've broken off from asteroids, and they tend to be smaller than 1 meter wide. So not very big at all. And all of those things are left over from when the solar system formed about 4.5 billion years ago. So everything in the solar system, including the sun, formed about 4.5 billion years ago. And the sun is a big ball of burning gas. And then there were leftover material. There were leftover rocks that made the 4 inner planets: Mercury, Venus, Earth, and Mars. And there were leftover ices and gases that made the gas planets: Jupiter, Saturn, Uranus, and Neptune. And then the other leftover objects made the asteroids, the meteoroids, and the comets. So we have asteroids, and they can be any shape and any size bigger than 1 meter. And they are rocky objects, much smaller than planets, but they do orbit the sun. And then we have meteoroids, but there's 3 different definitions of meteoroids. So meteoroids are the bits of rock in space. They are generally less than 1 meter wide. They can have broken off from other things, so they could be parts of asteroids that have broken off. And then if you take that piece of rock and it goes through our atmosphere, we call it a meteor. And that's what we also call a shooting star. So when we make a wish on a shooting star, what we're actually doing is making a wish on a piece of rock that is burning up through our atmosphere. And then if that piece of rock actually survives going through the Earth's atmosphere and lands on the surface of Earth, we call it a meteorite. And when we're able to find those meteorites on the Earth, we can take them and we can study them, and we can look at them in the laboratory and learn an awful lot about space and about the Earth as well. So sometimes the meteors are chunks of meteoroids that break off and burn up through our atmosphere. And sometimes they have originated from other planets. For example, if there's a collision on Mars and something smashes into Mars and fragments of Mars break off, they can then shoot down into the atmosphere of the Earth and land on the Earth as Martian meteorites. And then we can learn about Mars as well, which is really, really exciting. And sometimes these meteorites do impact the Earth, and we do have some craters on the Earth that you could go and visit. There's craters in America and other places, and they're quite spectacular. And we do believe that a meteorite that crashed into the Earth 66 million years ago helped cause the extinction of the dinosaurs. So I've had a question, why do they burn up? Well, the atmosphere of the Earth is full of gas and particles, and as these rocks fly through the air, they heat up because of the temperature and the pressure and the friction between the particles and the rocks, and they heat up and they heat up, and sometimes it's so hot that those rocks just sort of evaporate in the air, and sometimes they can withstand those temperatures and make it down onto the surface of the Earth. And sometimes they do completely disintegrate and they don't make it to the surface of the Earth, and we just see the meteors. It just depends on the size and the speeds. And there's a question, have I seen one? Well, I have seen meteorites, and I have held meteorites that have made it down onto the Earth. I've never found my own. And sometimes I have seen shooting stars as balls of gas. Sometimes they look like a burning streak of fire in the sky. And I saw one of those in Australia, which was really, really very cool. So do keep an eye out, and I'll talk about meteor showers at the end. And then we have comets. Comets are much, much bigger than asteroids and meteoroids. They live at the edges of the solar system. And the middle bit of the comet is called the nucleus. It's rocky and icy. And when comets live at the edge of the solar system, they're very, very dark. And as they come in towards the sun, they start to melt because they're big balls of ice and snow. And then you can see them in the sky, and they are very cool. So just to recap, a meteoroid is a fragment of rock or iron, or rock and iron sometimes, traveling through space. And if a bit of that breaks off and passes through the atmosphere of the Earth, it heats up and you can see it as a streak of light. And then if it survives going through the atmosphere and lands on the surface of the Earth, it's called a meteorite, and that's a fragment of this rock that strikes the Earth's surface. If they're very, very small, they don't do much impact. But if they are very big, they can actually cause a crater on the surface of the Earth. And this is one of the biggest meteorites known, intact. It's about 2.7 meters long and 60 tons in weight. So very, very, very heavy. And that's in Namibia. That's in Namibia. So if you hear the words meteoroid, meteor, or meteorite, they're all the same thing, but at a different point in their life cycle, whether they're in space, in the atmosphere, or on the surface of the Earth. Now, I've talked about meteor showers. So it is possible to see something called a meteor shower, and actually there is a meteor shower called the Lyrids going on at the moment. So I'll talk about that in a little while. And these are caused when the Earth passes through a cloud of space debris, and that means lots and lots and lots of shooting stars or meteors can pass through our atmosphere, and just in the space of one night you can see hundreds of shooting stars. But not all meteors come from space. When astronauts on the International Space Station use the toilet and they do a number two, they do a solid they do a poo, basically. What they do with the poo is freeze it and send it out the window, essentially, and then that burns up in the Earth's atmosphere. So sometimes the shooting stars that you're seeing are not beautiful rocks burning up in the atmosphere, but they're actually frozen poo burning up in the atmosphere instead. So that's a little bit more disgusting, but it's quite a fun fact for your family. Everyone loves a poo story, I think. Okay, and then asteroids are very similar to the materials that planets are formed from, but they're a lot smaller. They are from 1 meter up, but they're a lot smaller than a planet, but larger than a meteoroid. And most of the asteroids that we know about are located in between Mars and Jupiter, called the asteroid belt. And they're mostly found there because the gravity of Jupiter is so big that it keeps the rocks in place, it keeps the asteroids in place. But what might have happened is that there could have been a planet forming in between Mars and Jupiter, but again, Jupiter's gravity was so strong that it stopped that planet from forming in that area. And now instead we have this place in between Mars and Jupiter that's full of asteroids, full of lots and lots and lots of rocks, maybe even billions, that just didn't become planets, that weren't able to become planets. And some can be very, very small, and others can be very large indeed. So there we have another picture of the asteroid belt. And there's another set of asteroids called Trojan asteroids, which orbit around the sun at the same distance as Jupiter. But again, the gravity of Jupiter stops them from becoming a planet, but keeps them in place. So gravity is really, really important in anything to do with space. Actually, gravity is really, really important. And it's all to do with gravity. So the reason that those rocks are there is because of the gravity of Jupiter keeping them there. And Jupiter's a gas planet, so you couldn't stand on the surface of Jupiter, but there are some solid moons of Jupiter that you could stand on if you had the right equipment to breathe and that kind of thing. Okay, so moving on to comets. Like I've said, comets are objects mostly made of ice and dust. They travel through space, and we call them dirty snowballs because they're mostly made from ice and snow, but they also have lots of different chemical elements in them, and lots of different dirt and rock and gritty particles. Now, when they so comets live in a different part of the solar system. So you've got the sun in the middle, you've got the asteroid belt and the planets, and if you keep going past Pluto, you get to a place called the Kuiper belt and the Oort cloud. And this is so far away from the sun that everything is basically made from ice. There's lots and lots of comets there living in the Oort cloud at the edges of our solar system. Now, it would take hundreds of years for us to get to the Oort cloud. It's absolutely that far away. And because it's so far away, that's where the comets live, and we call them trans-Neptunian objects because they live past Neptune in this place called the Kuiper belt or the Oort cloud. And most of the comets and most of the objects that are this far away are icy because they're so far away from the sun. It's very, very cold, but they have other gases and elements in them as well. And we believe that there are trillions of objects in the Oort cloud, but we haven't really sent anything that far to measure it. So most of our ideas about the Oort cloud are estimates or guesses, educated guesses. But this is where the comets live, and the Oort cloud has many, many comets in it, but sometimes the comets do come in and visit the Earth. So when the comets live at the edges of the solar system, they are basically big balls of ice and snow, and they're dark. If we went to the edge of our solar system, to the Oort cloud, and had a look at comets, they would look like big black rocks, like giant black rocks, because they've got things like carbon in them, and carbon is like charcoal, like barbecue coal, it's black. But as they orbit the sun, they do something called a highly elliptical orbit. So most of the planets go around the sun roughly in a circle. They orbit the sun roughly in a circle. But comets live at the edge of the solar system, and then they shoot in and orbit the sun in this highly elliptical or stretched out orbit. And as they do so, as they come in towards the sun, because they're mostly made from ice and snow, they actually start to melt. And as they start to melt, we are able to see them. So they start to brighten up and they start to grow tails. So what happens is they start to melt, the ice turns into gas, and we start to see these cometary tails. And the tails are really clever because as the comet goes around the sun, the tail always points away from the sun, and they get longer. The tails get longer as the comet gets closer to the sun. And that's because the sun is spewing out energy and particles called the solar wind. And imagine the sun is blowing out the solar wind in all directions, and the solar wind, these high energy particles, blow the tail of the comet away from the sun, no matter where the comet is in its route around the sun. So it's very, very clever. And this means that as the comet comes in towards the sun, we from the Earth are able to see them. They're traveling very, very fast, but because they're so big and so far away, when we see them, they can actually stay in the sky for a couple of weeks at a time. And sometimes they can be bright enough that you can see them in the daytime. So because human beings can see comets without the need for technology, human beings have known about comets for thousands of years. And these are some pictures of artwork from a while ago. You might recognize in the top right the Bayeux Tapestry from 1066, and that's actually got a comet embroidered into it. So human beings have known about comets for a very, very long time, but because we didn't have the scientific knowledge, behind the comet, we human beings didn't know what they were, and they were named hairy stars because they looked like stars, but because of the tail they looked a bit hairy. And people used to think that they were a bad omen, and if they saw a comet in the sky it was going to be bad news. But that's not the case. Comets are, yes, they do come and we can see them from the Earth, but generally they don't actually impact the Earth, or they're not bad news. They're just really, really beautiful. And these are some pictures of comets in the sky. The bottom left one is from 1996, and I actually saw that comet with my own eyes, which was absolutely amazing. Comets can take from like 80 years to 200 years to orbit around the sun. So we don't see them very often. The next great comet in the sky is going to be Halley's Comet in 2061. 2061. So have a quick think about how old you're going to be in 2061 when the next great comet is going to be in our sky. It is a strange name, hairy star, and it's just based on observation. So people saw these objects in the sky and didn't know what they were and knew about stars, and they named them hairy stars, cometes, hairy stars. Comets are also visible from space. So this is Comet Lovejoy, photographed by an astronaut called Dan Burbank when he was on the International Space Station in 2011. And because we have really great technology now, we can actually visit comets and learn a lot about them. There was the Giotto spacecraft, which flew behind a comet. There was Stardust, which measured the tail of a comet. And then there was a Deep Impact mission, which basically flew up to a comet and fired bullets at it and then measured stuff that came off the comet. And then more recently, there has been the Rosetta mission in 2014, which visited Comet 67P and orbited that comet for 1.5 years and actually sent a lander down onto the surface of the comet, the Philae lander. It was absolutely an incredible mission, and it taught us so much about comets. The Philae lander, unfortunately, landed in a sort of like a cave in the shadows, and it was solar powered. So the battery couldn't recharge, and it didn't do as much science as we wanted it to when it was on the comet. But actually even landing something on a comet in space is quite a feat of technology. It's very, very cool. And why are we interested in comets? Well, there's a few reasons that we're interested in comets. Comets and the Earth formed at the same time during the formation of the solar system, about 4.5 billion years ago. And because comets live so far away from the sun, comets haven't changed that much in time, whereas the Earth has changed a huge amount. Most notably, there's been life that's formed over those 4.5 billion years. So if we learn about comets now, that can teach us more about what the Earth was like when the Earth was first born. And so that is why we are interested. That's one of the reasons we're interested in comets. And one of the other reasons is because we think that, or maybe a comet or an asteroid could have crashed into the Earth and caused the death of the dinosaurs, the extinction of the dinosaurs. And that top picture is a cartoon, it's not a real picture. And there is some speculation, some ideas that say maybe because comets are made from snow and ice, which is frozen water, maybe a comet smashed into the Earth and actually brought water to Earth, and that's why our planet has water on it. So those are some of the reasons that we're so interested in comets. And Comet 67P is huge. It's about 4 1,000 meters or 4 kilometers wide. And if that landed in England, it would take out the whole of London, right from Big Ben right across to the Tower of London. And I love comets because of one of the scientists that became very famous in comet spotting. So I mentioned William Herschel at the beginning, who was the first president of the Royal Astronomical Society. Well, Caroline Herschel, his sister, discovered or spotted 8 comets. She was one of the first women to be paid to be an astronomer. She won the gold medal of the Royal Astronomical Society in 1828. She was the first woman to win that gold medal. And another woman didn't win that medal until 1996. And Caroline had an incredible life. She was born in Germany. She moved to England. She did all her astronomy in Slough, in sort of west towards the west of London. And she lived until she was almost 98. She was 97 and a half before she died. And that was in the 1700s and 1800s. It was absolutely incredible that she lived that late, that long, considering when she lived. And she did die back in Germany. She went back to Germany before she died. But she's triumphant in being the first woman to be paid to be an astronomer. And she spotted these comets. And she actually did so much work that some of her work we still use today to catalogue what's up there in the sky. So she's very, very cool. Oh, and Felix has messaged that William Herschel lived near him. So you must be based near Slough. So the name of the comet that if it landed on London, Comet 67P, I can never say the proper name for it, so I just call it Comet 67P. It's not due to land on London, so don't worry. That's just to show you the scale of it. And there we go, a little nod to Caroline Herschel there. So we've learned about comets, asteroids, and meteors, and they are all objects in space, but they have similarities and differences. Comets and meteors both appear as streaks in the sky, but meteors, when they streak in the sky, it only lasts for seconds, but comets can last, they look like they do in the sky for weeks. Comets are frozen, they're full of ice and snow, and they can all be visible in the night sky with or without technology. Asteroids and meteors are made up of rock, and asteroids and comets orbit the sun. Meteors are too small to kind of orbit the sun. They don't have that same gravitational attraction. Most of the asteroids and meteoroids are found in between Jupiter and Mars. And we call meteors shooting stars when they shoot through the Earth's atmosphere, but they aren't stars at all. They are little balls of rock. And they usually burn up in the Earth's atmosphere. Sometimes they do make it to the surface of the Earth when we call them meteorites. And some people, for their job, actually is to go and collect meteorites. So they keep an eye on whenever there's meteor showers, and they keep an eye on when there's meteor showers, and they go to the Antarctic and they look for meteorites, which is pretty cool. Right, okay, so just some fun facts now about meteoroids, comets and asteroids. The fastest meteoroids travel through the solar system at a speed of about 42 kilometers per second. That would mean that those objects would be able to do a marathon in 1 second. So they would be able to run a marathon in 1 second. Comet, the name comet comes from the Greek word kometes, which means hair of the head, because of the Greek philosopher Aristotle, who observed comets as hairy stars. The first asteroid was discovered in 1801. It's named Ceres. It's almost as big as a planet. We kind of think of it as a dwarf planet now, along with Pluto, Eris, Meghmet, and Haumea. And it's 950 kilometers wide. So in 2006, it was sort of upgraded from an asteroid to a dwarf planet because of its size. And NASA, the European Space Agency, and other space agencies are always thinking about collisions and the chances of being hit by meteors and asteroids colliding with the Earth. There are lots of ways to avoid that. We don't want a big impact because that could be devastating to the Earth. It could be just as bad as it was to the dinosaurs. But some of the ideas include using nuclear explosions to break asteroids up, or other weapons or tools to deflect those asteroids and meteorites off their course. And this one I've already mentioned, Halley's Comet. Ooh, just let that spin. Halley's Comet last appeared in the solar system in 1986, and it has a period of about 80 years. So the next time it will be coming will be 2061, and some people have said to me that they will be about 50 by the time that comes again. Well, I'll be a bit older than that, but I won't tell you. And obviously being hit, or the potential to be hit by an asteroid or a meteor smashing into the Earth, is something that we are very aware of. And we call these potentially hazardous objects. And there are scientists whose job it is to track those. And what you're looking at here is the sun in the middle, and then the orbits of Mercury, Venus, Earth, and Mars. And those blue lines are some of the potentially hazardous objects that we are tracking all the time. And we are trying to check their position and check their distance from the Earth to make sure that they don't smash into us. Because, like I've said, we do think that an asteroid or part of a comet smashed into the Earth and caused the extinction of the dinosaurs. But we have ideas of how to deflect them or how to move them away. And NASA and the European Space Agency are always working on technology that could stop us being hit by a PHO, which stands for potentially hazardous objects. So, for example, there's the Asteroid Impact and Deflection Assessment mission led by the European Space Agency, which would, if they saw an asteroid that could be harmful for the Earth, could send a satellite up into space to hit that asteroid and deflect it off its course so it doesn't crash into the Earth. So that's one of the ideas of how to stop an asteroid or a meteor from hitting us. And we do know of cars and animals that have been hit by meteorites when they've smashed into the Earth. And you know, there are pictures on the internet of cars with big dents in because they've been hit by meteorites that have survived the burning up through the atmosphere and actually hit the surface of the Earth. Okay, so the last little thing I wanted to bring to your attention was these meteor showers. So when the Earth orbits through the path of a comet or some space debris, we have these regular meteor showers. And this is a time-lapse photo of meteor showers, but they can look like this. And they all come from one particular place, and that's called the radiant, and that it just depends on where the debris is coming from. And the radiant, or the middle of the meteor shower, is generally named after the constellation that those meteors appear to be coming from. So, for example, at the moment, this week, where yesterday and today are the peak, we have the Lyrids, which are coming from the Lyra constellation. And if you go outside at nighttime when it's dark, so sort of after 8:30 until dawn, until sort of 3-4 in the morning, and you kind of lie there and look up at the sky, you can see hundreds of shooting stars, and they're all coming from the constellation Lyra. But you can see in this table, there's lots and lots of meteor showers throughout the year, including the Perseids in the summer and the Leonids in the winter. But at the moment, if you can stay up until it's dark and go outside and look up, it might take 20 minutes or so for your eyes to get used to the dark, and you might have to wrap up warm because it's cold at night at the moment. But do have a look for the Lyrid meteor shower, which is happening at the moment. And there can be thousands, there can be hundreds to thousands of meteors during those meteor showers. So do keep an eye out for those tonight. Okay, the last little thing I'm going to do is there's a little quiz. There are 5 questions. I'm going to give you a few minutes to answer those questions. Question number 1, what is it? This is sometimes called a dirty snowball. Question number 2. These are tiny rocks that burn up in the Earth's atmosphere. Question number 3. This is a rock made from similar material that form the planets. Question number 4. These are pieces of rock which are smaller than asteroids. Question number 5. These are mostly located between the orbits of Mars and Jupiter. And again, you can chat to the person next to you, or you can message me in the chat. So I'm getting some answers now, but I'll just give it a minute. Okay, right. So there's a question about how the shower names are similar to zodiac horoscopes. Well, the zodiac horoscopes are actually named after constellations, and the meteor shower names are also named after constellations. So there is an overlap there. Okay, we're getting some great answers here. Excellent stuff. Okay, so question number 1. These are sometimes called dirty snowballs, and the answer is comets. So well done if you got comet. Question number 2. These are tiny rocks that burn up in the Earth's atmosphere, and these are meteors. Very specifically meteors, and not any of the other meteor type names. Question number 3. This is a rock made from similar material that formed the planets, and that is asteroid. Well done if you got asteroid. Okay, these are pieces of rock that are smaller than asteroids, and they are meteoroids. So if you forget which type of meteor is which, just remember asteroids and meteoroids are both in space. And finally, question number 5. These are mostly located between the orbits of Mars and Jupiter. Any ideas? Mars and Jupiter. Of course, it has to be asteroids, because they are located in the asteroid belt, which is between Mars and Jupiter. Okay, so just a pat on the back there if you got those right. Well done. That means that you've been doing some good listening. And what I'm actually going to do now is stop sharing the screen and bring my face back on. And if you have any other questions, you can write them in the group chat. You can send them to me and I can answer questions. They don't have to be about the topic today. They can be anything about space. We have had one question saying, is there a direction to look at when trying to look for the meteor shower tonight? Well, because they're in the constellation Lyra, you have to look roughly northeast, and an elevation, it sort of depends on where you are, but if you look northeast to the northeast direction late in the evening, you're looking for a bright star called Vega, which is part of the Lyra constellation. And to the top right of the constellation Lyra, you'll see the radiant of the meteor shower. So the majority of the meteors are coming from there. But don't worry too much. You can, you don't have to look in that direction. You should be able to see meteors all across the sky. This question saying, have I ever been to space? No, I haven't ever been to space yet. I would like to go into space. If you are applying to be an astronaut with, for example, the European Space Agency, you have to be a minimum age of 27. So last time there was a call for astronauts, I was too young to apply. So I haven't applied and I haven't been into space yet. But it is something I think I will do in my lifetime, even if it is like a retirement plan and I go up into space using commercial spaceflight rather than training to be an astronaut. And I bet, or I hope, most of you that are listening today would like to be astronauts as well. Okay, has a plane ever been hit with a comet or an asteroid or meteor and it crashed? I don't know, to be honest. I don't think so. But when you're flying, when you're a pilot, whether that's in the Earth's atmosphere or in space, you do have to look out for micrometeorites, which can damage your spacecraft or your aeroplane. But I don't know of any that have sort of fallen out of the sky because of crashing into something in space. Do I have a favourite comet? Probably Hale-Bopp, which is the one that I saw in 1996. So that's why I like it, because I saw it in 1996, and I don't think that one's going to come back in our lifetime. So I was really lucky that I was sort of alive and able to see that in 1996. It doesn't matter where in the UK you are to be able to see the meteor shower. Just look up. If you look up and you stay out, and you let your eyes acclimatise to the dark, then you should be able to see the shooting stars, the meteor shower. And also at the moment in the sky, the Starlink satellites that are being put up by Elon Musk, you might be able to see those as well. It is difficult to train to be an astronaut. It's you have to have a really good background in whatever job it is that you do, whether that's a scientist or a researcher or an engineer. You have to be working in that field for a few years to get some expertise, and then you have to astronaut training. First of all, getting onto the astronaut training program is difficult, but then astronaut training is pretty rigorous. You've got a lot of classroom activities. Even though you're an adult, it's still called a classroom. You have lots of physical training, so scuba diving. You have to be very physically fit. You learn how to speak Russian. You learn how to fly an aeroplane. You have to do lots of team building exercises and teamwork. So it is difficult. It takes a couple of years to train to be an astronaut. But I'm sure it's completely worth it when you get your first flight up to the International Space Station and you get to see the Earth from space and bob around in weightlessness and that kind of thing. How far away from Mars is from Earth is Mars? Well, if we travel directly, it would take about 6 months to get to Mars. So spacecraft take about 6 months to get to Mars. If we had humans on board, it would take longer because you'd have to take a different route, and you'd have to sort of balance out the fuel and stuff, and it would take a couple of years. So being in lockdown at the moment is really good astronaut training. If you're interested in being an astronaut going to Mars, can you imagine being in lockdown in your spacecraft for 2 years with only a handful of people? Is very similar to being in lockdown now. So when you feel a bit down about being in lockdown at the moment, just imagine you're an astronaut on your way to Mars. If I could go into space and do a particular job, I'd still like to be a scientist. I'd like to do science experiments in space. Astronauts do all kinds of science experiments, from trying to grow plants to trying to see how mice react, to even doing experiments on their own bodies, because our own bodies are a great experiment, and human bodies do react differently to in the space environment to on Earth. I first got a telescope when I was about 13, but I lived in London. I grew up and lived in London, so the views that I got were not as good when I was younger. I live somewhere else now and it's a lot darker, and I live near the sea, which is nice because it's dark and it's quite private, and so the skies are a lot brighter, so that was good. My favourite dwarf planet is probably Pluto. I think Pluto's amazing. It's an incredible little planet, and there's lots more to learn about it. So there's lots more to learn about it. Does space travel cause a lot of pollution? Well, not air pollution as much on the Earth, but we are kind of junking up space with satellites and things. So we do have to be mindful about sort of putting too much stuff into space and polluting space in the same way that we've kind of polluted our oceans and our planet. So we do have to be careful. If you're interested in space jobs and careers in the space industry, a really good website to start with is spacecareers.uk. and there's lots of opportunities for young people for work experience and information about space. And if you are 13 onwards, you should definitely go to Space School UK, which is a residential in Leicester all about space. Obviously, it's not running at the moment because of lockdown, but when things go back to normal, have a look at Space School UK. Okay, the other thing I'm going to do actually is if you do want recordings of previous lessons, or if you want to get in touch with me, I'm just typing my email address into the chat. So if I don't answer your question today, because we've only got 5 minutes left, or if you want to get in touch with me, I have written my email address down in the chat. You can also email me via Eventbrite. That does get to me as well. One of the things I would like you to do actually is email me with suggested topics for the next lessons. So in 2 weeks' time, I'm going to repeat this one, but in 4 weeks' time, I'll run another lesson, another session. And if you have any topics that you really want me to cover, then email me and I will try and cover those. Okay, 2 more questions. Let's have a look. We've got 2 more questions. Let's see. So there's quite a lot of questions about who names the things in space. It depends who's discovered them and when it was. So when a long time ago, like for example, William Herschel, he had actually named the planet Uranus Georgium Sidus, which means the Georgian star. He named it after the king at the time. And then some European astronomers said, no, you shouldn't name something after a person, so they changed the name to Uranus. Now we have an organization called the IAU, which is the International Astronomical Union, and they do a lot of the naming, whether it's numbered naming or named after something. But you can apply to have your name, have like an asteroid named after you. There's lots and lots of different ways of doing that. So, but you have to be quite established to be able to nominate yourself to be named after an asteroid. Okay, last question. If I could pick any planet to go to right now, what one would I pick? Well, my favorite planet's Saturn, so I definitely like to go to Saturn. Saturn's a gas planet, so I couldn't actually land on Saturn, but I would like to investigate some of the moons. There is a moon of Saturn called Enceladus, and it's a very small moon. It's only about the size of England, but it's covered in an ice crust, and there are plumes of water spewing out of the cracks in the ice crust, and we believe that there's an ocean underneath the ice. So I really like to go to Enceladus and drill through the ice and measure what's in the ocean, because there might be microbial life in the ocean of Enceladus. So if I had to kind of bet on where there might be life in space, then I would like to bet on Enceladus, but not like intelligent life, like microbial life. So there we go. So that is the last, we've run out of time for today. Like I said, you can get recordings of previous sessions, including this one. You can also email me and get in touch with me on social media. If you've got any further questions, if I wasn't able to answer your question today, or if you have any suggestions for future sessions, then do get in touch. I hope you enjoyed today's session. I hope you learned something and had fun. Don't forget to have fun while we're in lockdown. Stay safe and well. And like I said, if you feel a bit bored or something during this lockdown situation, just pretend you're an astronaut on your way to Mars. Thank you very much. Do keep in touch. Take care of yourselves. Stay safe and well. And goodbye. Take care. Bye.